Hello everyone. In this video, I'm going to explain about classification of memories. So in this classification, we have semiconductor memory will be there. So in this we have two types of memories are available. One is ROM and another one is RAM. ROM is nothing but read-only memory and RAM is nothing but random access memory. And coming to this read-only memory, nothing but read-only memory which is manufactured with metal oxide semiconductor or maybe by using a bipolar transistor. So when you're using the bipolar transistors which are the memory cells within that ROM, then we have two RAMs will be available. We have two ROMs will be available. One is mask ROM and another one is that PROM, that is that programmable read-only memory. And when you're using a memory cell within that read-only memory which is a metal oxide semiconductor, then we have that mask ROM, PROM and EPROM will be available. And within this EPROM we have UV EPROM and EEPROM will be available. So here ultraviolet erasable programmable read-only memory, that is nothing but UV EPROM. And coming to this EEPROM, electrically erasable programmable read-only memory. So like that, here there will be a classification in that read-only memory. And coming to this random access memory, again this random access memory is manufactured with that bipolar transistor or metal oxide semiconductor. That is nothing but here they are the memory elements. That is the memory element which can store one bit, either 0 or 1. That may be done with that either bipolar transistor or metal oxide semiconductor. So when you're going for the RAM within this bipolar, then we have static RAM is available, and at the same time when you're going for the MOS, then we have static and dynamic RAMs will be available. So this is about that the classification of semiconductor memories. According to the functional relationship with the CPU, there is nothing but central processing unit. The memory is classified into main memory and auxiliary memory. So this is based on that the functional relationship with that CPU. So here the classification as main memory and auxiliary memory. So coming to this main memory. So this main memory is also called as primary memory or core memory. So whatever that central processing unit doing any operation, the fetching of the data, the fetching of the code, nothing but instruction, and after performing that arithmetic and logical operation, we will get that output result, or in between that processing we may get that temporary results, and everything, that is the instructions which is to be executed and the data which is to be fetched and the output results are the temporary results that are stored in that main memory. That is nothing but the central processing unit will do every operation through this main memory. So that is why here you are calling this main memory as a core memory. And coming to the cost, which is very high simply. And coming to this auxiliary memory, which is nothing but a secondary memory. So generally the memory which is connected as a peripheral device to the computer, we will call a secondary memory. So in this secondary memory we can store the data, but the data which is stored in the form of magnetic energy. And coming to that data transferring rate, that is the speed, the main memory has very high speed when we compare with that auxiliary memory. But here one advantage is there about that auxiliary memory. We can store a large volume of data in auxiliary memory. That is the advantage of that auxiliary memory. So this is the classification of memory based on that the functional relationship with that CPU as main memory and auxiliary memory. And here we have a block diagram is there. Just see this one. So there is a CPU, that is nothing but memory organization here, this block diagram representing. So CPU, main memory and auxiliary memory. So this main memory which is very nearer to the CPU, that is why the accessing speed of the main memory very fast for that CPU compared with this auxiliary memory, and this auxiliary memory is far away from the CPU, that is which is connected as a peripheral device. So that is why this auxiliary memory is slow when compared with this main memory. So this is about that, the main memory and auxiliary memory. Here the memory is classified based on the accessing method. That is, according to the method of access, the memory is divided into two categories. One is direct access memory and another one is that sequential access memory. Here the data write into the memory or the data read from the memory, that can be done in two methods, that is direct access or sequential access. So based on these accessing methodology, the memory is divided into direct access memory and sequential access memory. So first we will see about that direct access memory. In this, the data can be written into the memory in random. That is, here the data can be distributed randomly within that memory. Here the example for this direct access memory is random access memory, that is RAM, and we have one more example is there, magnetic disk is also one type of direct access memory. And coming to this sequential access memory, here in this memory the data can be written or read in order, but when you're going for the direct access memory there is no order. Okay, so here in this sequential access memory we cannot access the memory locations at random unless the first memory location is accessed. There is nothing but after accessing that first location, that is nothing but the first memory location, we can go for that next location. The best example for this sequential access memory is that magnetic tape. In this magnetic tape, we have to access that each memory cell in order. But coming to this direct access memory, there is no need of accessing the data in order. We can access that any data at any location within that memory. That is nothing but direct access memory. So this is the classification. That is nothing but direct access memory, sequential access memory according to the method of access.